So let's address the question of value creation. One thing is to be able to value something at a fair price. So anything 0 NPV is fairly priced, right? So we started out saying we have some sort of value, which is the free cash flow divided by cost of capital and constant growth. And if we take a look at this free cash flow, that's essentially earnings minus net investment. And what is that? Well, earnings is essentially the return on your invested capital. And net investment is the required growth in your invested capital. So essentially what we're saying here is, if we sort of simplify this term over in terms of this, it's invested capital return minus the growth divided by the cost of capital minus the growth rate. And this is quite helpful. Now we have a function that we can work with and we can try to understand what's going on. So if we have a situation with return being greater than cost of capital, what does that imply? Now, what it gives us here is we can look at our expression. And if we have a return greater than cost of capital, we should probably, that should imply that we have positive NPV and we would like to grow our firm. Now, if we take here this value function and we let growth go towards the limit, which would be the cost of capital, because of course, as we talked about earlier, the cost of capital can't be larger than growth, or growth can't be larger than the cost of capital. That would sort of negate the simplified model that we have here. So if we let growth go towards the cost of capital, then value will go towards infinity. Now, what is the takeaway here? Well, our takeaway is pretty straightforward. If we have a positive NPV project or positive NPV, so we have a larger return than cost of capital, we want to grow it as much as we can. Growing it into infinity is probably not going to happen, but as you can see here, basically this is value creating. Now let's say that we have a situation where return is equal to the cost of capital. Now this would be a 0 NPV project, right? Now putting this into the context of what we have here, value would be equal then to the invested capital, and since R is equal to K, it would be K minus G over K minus G, which is simply the invested capital. And then you say, well, that doesn't sound too good. Well, actually, that's not too bad. A 0 NPV project is a fairly priced market transaction. So really what you're getting is the fair return on your investment. The final situation here would be that we have a return that's smaller than the cost of capital. Now, that's obviously not what we want. And in that situation, if we now take the limit again and we grow until the return, which is the smaller of K and R, which means the value would go to 0. And that's straightforward to see, as if G goes to R, this term becomes 0 and the value becomes 0. So the second here with a 0 NPV would be what we refer to as value conserving. And this would be value destroying.